inches per second.
No, but this was over the whole, this was the average speed from 4 to 4.1. We don't know how fast I was moving at that instant.
Why don't we just take it really close with the...
Well, we're going to guess again. Here's what we're going to do now.
Black contact here at 0, aren't you?
We're going to now,
No, you're negative.
we're going to now find the slope
It's physics.
in the last tenth of a second. Not tenth of a second, hundredth of a second. We're going to find the average speed in the last hundredth of a second before contact. Which means I need somebody, I know f of 4.1 is still 30. And I know that 4.1 minus 4.09 is 0.01. What I don't know is what happens when I put 4.09 into this parabola.
No,
So
but
somebody
you
with a
do.
calculator has to trace or plug in or do something.
Because you only lifted off at 4.1, didn't you?
No, I started moving at 4.
Oh.
And then I connected at 4.1. That's why 4.1 is the speed we're interested in.
Oh,
24.3, good. And then if I work this out, I'm going to get 5.97, no, 597? Is that right?
Why?
No. I don't know.
Find out for me quickly.
Wait, you get 5.7
Wouldn't it
on top.
Yeah, and then it'll be 57.
Oh, so it's 570
Oh, just kidding.
inches per second when I multiply. Is that right?
No.
If you got 5.7 on top, which you're correct,
Yeah.
and then multiply that by 100, because dividing by 1/100
Oh,
is 6
yeah.
I have a question.
So 500, okay, so now, first, on the first punch with my average speed of 5 inches per second, I would have hit her at 5 inches per second. On my second punch, if we take the average of the whole last tenth of a second, we're looking like 300 inches per second. We take the average of the last hundredth of a second, it's 570. So obviously, and I was still accelerating. So it was still going faster and faster. Yes?
I don't get why. Where's the 4.09 from the
Okay, follow me over here a sec, Dina.
I hate you.
Oh,
You-
from there to there.
From there to there is the tenth of a second. That's my first slope I found.
Oh, okay.
Then I decided, well, what about in that last hundredth of a second?
Okay.
Now I'm going to find the slope between 2 points in the next thousandth of a second. Okay? So I'm going to need some help filling in the point again. It's still going to be f of 4.1, but now it's going to be f of 4.099. So it's like making your table for your limits. So this is going to be 30 minus something I'll need help with over 0.001.
Wait, sorry. How did you get the 24.3?
Drew told it to me. He plugged 4.09 into my function, which meant plugging it into this parabola.
Okay.
29.08. Yeah, 29.403.
29.4, I'll go ahead and stop there. So now it's going to be, okay, 30 minus 29.4, Drew? Is 0.6
Yeah.
times 100? Actually, 0.6 times 1,000.
It's 600.
600 inches per second.
I have a quick question.
What we should get if we went out more places is we'd get 599.7, and we'd keep getting 599, but it'll never get more than 600. If we plug in more, it'll keep getting closer to 600 or rounding to 600. It will never go above 600. So what is our guess for how many inches per second my fist was moving at 4.1 seconds? 600 inches per second. That is our guess for the instantaneous rate. We got it by shrinking averages. This is the same thing we did at the beginning of the year.
I have a question.
Yes?
Can we start by just plugging in the closest one, like 4.0999, and then go from there? Because
You can, but you still have to check a few closer because you have to see the trend. Like, I'm actually just shutting this down at a time, but really, I don't know for sure that if I keep going, it won't go over 600.
Well,
Like, from this information, you don't know that.
well, then how do you know it?
Because I've done this a million times. Sorry, but if we plug in, and actually because I cut Drew off, it was 403, so this is really supposed to be 599.7.
So it never gets up to 600.
And
No, well, your
cut.
calculator will start rounding to 600 in about 2 more steps. But it'll never go above it.
So what does that all just like tell us?
that tells us that we think by smaller and smaller averages, okay, we think that 600 inches per second is the best guess for what, follow me over here, okay, for what the instantaneous speed will be of whatever the motion that this graph describes. We also think, okay, if I do a graph from here to here, if I find the slope from here to here, I'm finding the slope of a secant line. Secant is Latin for sever. Finding a line, the slope of a line that takes a shortcut. Okay? Martino said this well yesterday, as we shrink this interval, okay, what we start doing is we stop finding the slope between 2 points, and we start finding the slope of a tangent line which barely touches the parabola at 1 point. And that's our guess for instantaneous speed. Now this is a guess, and this is how we did it at the beginning of the year. Okay? Take a deep breath. Now we're going to do something a little different. This is our averages. This is slopes. This is where this all comes from. Now I'm going to write a different slope equation. Okay, and this slope equation is going to be f of x plus h minus f of x over h, where h stands for delta x. Does this look familiar?
Isn't that just a formula?
Yeah.
Yeah, this is our difference quotient from the beginning of the year. And if I slap this on the front, this is our derivative formula from yesterday, which only half of you saw. Okay? This is our derivative formula. What this means is, okay, Connor, are we still facing this board?
We are.
Okay, thank you.
A little bit off.
All right, let's get that in there.
Yeah, OCD boy.
That gets this one? Really? Oh, haha, thank you. Okay, so this is our derivative formula, okay? This means as the distance between the x points shrink to nothing, okay? Now the problem with this formula to start with is if I put h in, like Adina noticed a few minutes ago, if I let h equal 0 here, I will always get 0 over 0 to start with. So the key is to manipulate things algebraically until you have a situation where you can let h equal 0, and then you have a function you can deal with. F of x in this case is 3,000 x minus 4 squared. Okay? Are you ready for some serious algebra?
Not really, but
Good. F of x plus h is 3,000 x plus h minus 4 squared. So now we're going to find f prime of x, which is going to be the limit as h approaches 0 of, I need to erase this,
Wait, so now are you just gonna
write those two together.
yep. So now I'm going to have 3,000 x plus h minus 4 squared minus 3,000 x minus 4 squared over h, and I'm going to find my derivative formula.
Sweet.
Does this look like fun?
I can see the happiness in his face.
I can. All right, let me give you one little possible ray of sunshine to this. The 3,000 is in both terms. I can factor it out.
Yeah.
Also, I can write it at the beginning if I want to. A limit is, as I mentioned briefly before, a semi-permeable membrane. No, I said that as sigma. A limit is like a sigma. It's a semi-permeable membrane. This coefficient, 3,000, can come to the outside and I can rewrite it